Hi, this is King of Review. Here we have a general logarithmic function, f of x equals log base a of x, and we need to determine which of these 6 statements are not true. So let's start at the beginning. A says the domain and range are positive real numbers. Well, we can figure that out pretty easily by looking at a graph. If the base a is greater than 1, then the logarithmic function is increasing. It starts out negative and gradually it turns positive and gradually increases. And it crosses the x-axis at the point x equals 1. That happens because any number a raised to the 0 power is equal to 1. So when x is 1, the power must be 0. Now right away we can tell statement a is false. As we can see, this graph goes into the negatives. F of x here, what a logarithmic function equals, is an exponent, and exponents can certainly be negative. So while the domain of this graph is positive real numbers, the range is not. So A is false. That's one of the ones that's going to be not true. Right away we know D is not the right answer because D does not include option A. Let's look at B. If u is less than v, then f of u is greater than f of v when 0 is less than a, which is less than 1. So we need a new graph for when 0 is less than a, which is less than 1. When a is less than 1, we have a number less than 1, and when you raise the base, a number less than 1, to any exponent, it just gets smaller, which means this graph is essentially flipped upside down. It becomes a decreasing graph that still crosses the x-axis at x equals 1, but now of course it's flipped upside down. It's reflected over the x-axis from the original graph where a was greater than 1. Well, let's see here. If we have two numbers u and v, u is smaller than v, so maybe here's u and here's v, just picking 2 points on the x-axis, then this statement claims f of u is greater than f of v. Well, f of u is up here, and f of v is down here, so that does seem to be the case. Since a is between 0 and 1, the graph is decreasing, so b is correct, which means b should not be part of our solution. The graph does pass through the point 1, 0 in both of these instances, but it does not have a horizontal asymptote on the x-axis. In fact, it crosses the x-axis, which right away means the x-axis cannot be an asymptote. C is false, and it should be part of our answer, which it is in both of the options we have left. D says f of x times y is equal to f of x plus f of y. This is log of a, x times y, and there's a property of logs which says we can split that up into the log base a of x plus the log base a of y, which of course is just f of x plus f of y. So D is correct. It should not be part of our solution, and indeed D is not part of choices A or B. Now E takes the same property as D and reverses it. It puts the addition inside the original function and then has the product of the two individual functions. That does not work. This property relating multiplication to addition only works the way it is in D. So E is false. It should be part of our answer, so it's looking like B is going to be the right answer here. Let's make sure by seeing if F is also not true. We are looking at the graphs of log base a of x and a to the x, and let's just use the simpler a is greater than 1 graph. If we look at y equals a to the x, it will look something like this. It's exponential growth since a is greater than 1. So here's y equals a to the x versus y equals log base a of x. And now these two graphs are reflections since they are inverses. They are a reflection over the line y equals x. The problem here is that choice F says y equals negative x. Y equals negative x goes in the opposite direction, and these two lines are clearly not a reflection of each other over that line. So, choice F is definitely not true, and our correct answer is definitely B. Thanks for watching.